Oh, hello. I have not introduced myself. My name is Cesar Sewell. I am a research computing facilitator or research computing associate. That's my official title for the Center for Advanced Research Computing. Um, so we do a lot of things at CARC, such as provide and maintain research computing resources. And we also do stuff like this workshop, provide education and training and all that kind of fun stuff. So I'm going to link our website in case somehow you don't know what our website is. I put that in the chat. What I would like to bring your attention to is if you go to user information and then user guides, software and programming, there's a bunch of guides specific to some popular software that is used on our cluster. And since this is the Python workshop, I want to bring your attention to this using Python page that we have. And this is information that is specific to our system. So you may have noticed like there is a wealth of very high quality information about how to use Python. And for the most part, you can just follow along. But there's a couple initialization steps that you should be aware of when you're running on our system. So first is we have the module system, and we have multiple versions of Python available on our cluster. So use the module system to kind of activate Python. And actually, maybe I should bring up a terminal. Let me go back. Okay. We should all see a terminal, right? Let me actually focus the share. Okay, so let me log in SSH and then type in my username. Sorry, discovery.usc.edu. And then put in my Duo authentication choice. And then do the Duo thing. There it goes. Okay, so the module system, I'll clear the screen out. Module avail Python. If you would just log in and type module avail Python, we'll ignore these because these are modules that I created myself. But you should see something like this: SPAC apps, Linux, LMOD, Linux CentOS 7, x86-64, GCC 8.3.0. So these are versions of Python that have been built by CARC staff with the GCC 830 compiler. So we have these versions, and if you would like to use Python, oh, and there's also this letter D, which means that's the default module. So when you type module load Python, that's how it decides which one to pick because there's different versions. So if you leave off a version, it'll just go with the default one. So module, so I'll do this, which Python. The operating system comes with version of Python, and we don't want to use that because there's no packages installed with it. It's kind of a useless version of Python. So I'll do module load Python, and then I'll run this which Python command again. So we can see that it returns this really long, kind of scary looking string, but at the very end, you see there's a Python. So that lets us know that we're using Python 392. And if you want to be extra sure, you can type Python -- version, and it'll return Python 392. Or if I wanted to use, let's say Python 376, because that's my script can't make use of the newer Python features or something like that, I could do module load Python 3.7.6. And LMOD lets you know that the version of Python that you're going to be using has changed. which Python. And it's an equally scary looking long string, but a little bit has changed. Python -- version, just in case you're untrusting of file paths, I guess. So yeah, so if you were to run Python on the cluster like this in the command line, this is how you would go about picking a different version. And if you use a different compiler, which I don't know how many people are interested in doing that, it's pretty similar. Module load GCC, let's say 9. It says your compiler swapped. These modules have been reloaded. Module avail Python. And these are the, oops, right here. These are the versions of Python that have been built with GCC 920. So again, I don't know how many people in this room are really interested in using different compilers. So maybe this is not like a very helpful information, but just know that that's there. Okay, now I'm going to go back to the website. Okay, I'm just like flying around through different windows and screens and stuff. Okay, so here's our website. So this is what I was talking about: module load, module purge, if you want to clear out all your modules. So we know how to find Python. I'm going to skip all of this stuff right here and go to this important. This part is more important. Assuming you have a Python script, this is how you would go about running it as a job script. So hopefully you're all familiar with that process of running a job, but a very brief summary is you have this file that we call a job script, and there's different pieces to it. So the first is this bin bash line, which says that this is all bash syntax. The second part is information to our job scheduler that describes the type of compute resources that you want to use and maybe some features about the job. For example, this account is saying which account to charge compute time to. And then the rest is what happens in the job script. So in our job scripts at Carc, you have to load a Python module, and then you launch your Python script with this Python script.py syntax. So I will put the link to this page in the chat so you can review. Oops, did not mean to click on whatever I just clicked on. So you can review. And then there's also just information about running jobs and packages, which is a little bit beyond the scope of this presentation, although I'm happy to talk about it. But the main goal is just like, assuming you've never used Python, how do you use Python? So this is just a little bit of like, how do you find information about our specific setup that we have? Okay. So next, before we start getting into the material, I'd like to show you, we're all going to run the examples that they give us in the software carpentry workshop. We're going to use a new service that we have launched at Carc called Open On Demand. So I'm going to paste this into the chat. And what Open On Demand is it's a service that lets you run stuff on compute nodes, but you can do it all through the browser. So one of the things that it gives us access to is something called Jupyter Notebooks, which is kind of like what they call like a computable document or something. So this is helpful for a lot of reasons, and we'll see why it's so good in this workshop. But for now, it's just like something that's popular that people like. So click on this Carc On Demand page, and kind of like wrestling with the Zoom. window. Sorry. All right. So assuming everyone's on this page right here, Carc on demand. Oh, thank you. Okay. So there should be a page that says interactive apps and then something called Jupyter Notebook. So if you click on that, right now you're just seeing a red screen, but if you haven't authenticated, depending on, if you're how you're starting your workday, it may ask you to authenticate and you use your normal USC credentials, but I've done some USC stuff today this morning, so it just logs you in. Give everyone a moment. So hopefully you all see this page here, a bunch of stuff that you can fill in. What we're going to do is we're going to use this to request resources. I'm going to put, here we go. The workshop is scheduled for 2 hours. I'll just put 2 hours. 1 CPU is fine. Everything else default. Account, make sure it's the correct account. Plus there should be discovery. Everything, I think you can just leave the defaults and then click launch. And then what's going to happen is a job will be submitted. Let's see. And a job has just now started. And I have a little window that says connect to Jupyter. So hopefully everyone that is following along, they see this connect to Jupyter button. I'm not sure how long it's going to take. So while that is waiting, I'll just go back to my terminal real quick. Just, I guess, to pass the time a little bit. And I'll type SQ-U and put my username. And I can see that I have a job currently running. And the job is called sys dash, and then it gets cut off. That's Jupyter Notebook running. That's a job that, yeah, so it's requested a job, it's requested 1 CPU for 2 hours, and so that's running on this compute node E19 dash 21. Okay. So is there anyone that is not able to start their Jupyter Notebook session right now? And then let me just wait for everyone. If there's anyone that's having problems, anyone that wants to have a Jupyter Notebook, yeah, I'm going to click on this button, connect to Jupyter. I'm deliberately being kind of slow right now, so people can follow along if they choose to follow along. I'm not sure what you see because I've actually been messing around with my Jupyter settings, but you'll probably see something like this: select kernel, Python 3, IPy kernel. Just click select, leave that alone. You may have this little browser, and it should start with the slash. And this should be your home directory. So what I'm going to do is I'm going to save this notebook. Oh, I'm going to rename it actually. Rename notebook. And I'm just going to call it Python Workshop. Okay, and then periodically I'm just going to hit the save button. And so part of the nice thing about using Jupyter Notebook is as we go along, you're going to have like a log of what we did today. So hopefully everyone's at this page or at this state. Okay, and then one more like getting ready thing is there is some sample data that we're going to be using. So I'm going to copy this link here and paste it into the chat. And don't click on that just yet. What we're going to do is we're going to save this .zip file into our home directory. So the way we can do that is if you have a terminal, you can just do that from the terminal. But since I want to show off our fancy Jupyter notebook thing that we've got going, we'll do it from here. So if you do File, New, there should be a terminal tab that you can click on. So I'm going to do that. Oh, shoot, I just realized this won't work. Because I'm on a compute node and there's no internet on compute node. So actually we do end up having to do this from the terminal. But if you wanted to, I guess I'll just show off anyway. Yeah, you can create a terminal, and if for some reason you've got to do something that can only be done through the terminal, Jupyter Notebooks allow you to do that. Okay, so what I'm going to do instead is I will share my terminal again. Good thing I did not close that terminal window. So here I am in my home directory, pwd. And so what you're going to do is you're going to take that link that I pasted into the chat and just type wget and then paste that in. And if you're unfamiliar with wget, what it does is it downloads a URL. So download it pretty quickly, 0.02 seconds. So if I do ls-lrt, there it is at the bottom, the newest file at the bottom. Not very big, so I'm going to unzip it. Am I going too fast? I'll just kind of chill for a little bit. So what I did was I started a terminal, login, and I ran wget on this file. I'm going to run unzip python -novice inflammation data.zip. Okay, and then it creates a directory called data. And there's the file. Sorry if this is like kind of hard to follow. I have a lot of stuff in my home directory. Looks kind of ugly. But just trust me, in my home directory, there's a folder called data. And in that data folder, there's a bunch of these .csv files, inflammation1, inflammation2, blah, 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 to 12. And there's a small one, small 2, small 3. So again, I'm just kind of meandering and being slow to make sure that anyone that wants to follow along is able to follow along and to download files they need. And okay, so at this point, could I get a thumbs up from people who want me to go, I guess, to keep going? Or if you having trouble, put something in the chat. Or you just want to watch, that's fine too, I guess. Okay, I've got some thumbs up. Okay. All right, now I'm going back to sharing this screen again. And of course, like my screen flies around. Okay. I'm gonna click here, Python fundamentals. Oops, I did not mean to click on that button. Okay. And I'm going to copy that and I'm going to paste this URL in the chat just in case people can follow along. Oops, wrong one. I'm going to close that. All right. Get my notes ready. All right, so we've got a notebook that's ready to take our commands. We have this little prompt right here. So Python is an interpreter, which means that you can type some text to Python and then Python will evaluate it right then and there. So I'm going to type something like they say on this left-hand side, 3 plus 5 times 4. And the syntax of Jupyter Notebooks is not press enter, but press shift enter. And it will evaluate the statement that you have typed in. So Python can run commands. Like I think all of them, but maybe there's one that I haven't heard of that doesn't do this. But yes, there's a concept of variables in Python, like in most programming languages. And so the way you assign a value to a variable, let's say we wanted to create this weight in kilograms variable, you just use the equal operation. So 60 equals, or weight kilogram equals weight 60. So what we've done is we've created a variable, and now anytime we want to use the number 60, instead we can type in weight in kilograms. And then there's some kind of interesting rules that Python has for what you can name a variable. So include letters, digits, or underscores. I did not know this, but you cannot start it with a digit. I've never had the desire to use such a name for a variable, but you can't do that in Python. And case sensitivity is also important. So that's like, oops, of course I'm like in the wrong window. But weight is not the same thing as weight with the capital is not the same thing. So that's an important thing to keep in mind. All right. So there are data types. There are a lot of different kinds of data that you can have in Python. And Python also has just built-in data types. And then there's other packages that extend Python and create new data types. But some very, very basic data types that most people may interact with are integers, so whole numbers like 1, 2, 3. Floating point numbers, which is a fancy way of saying, or confusing way of saying decimal numbers. So like 1.1, 1.2, 1.3. And then there's strings, which is kind of a weird way of saying text. So in this example, weight kilogram, that is an integer. So we're saving integer data. There's another patient ID equal, to save a string, you put it between these little single quotes. So this is 001, the string. It's not number 1, it's 001, like text. So like I said earlier, you can use variables like you would use the regular data type. So for example, if we wanted weight in pounds instead of weight in kilograms, we could do something like this. Weight in pounds is equal to, and then you put in the conversion factor, which I don't know off the top of my head. So I'm going to put my faith in the software carpentry people. And apparently it's 2.2. So weight in kilograms. So what this is saying is take the value of weight in kilograms, multiply it by 2.2, and assign the result of that into weight in pounds. Okay. So that's an operation on an integer. You can also do operations to strings. Here's one. Patient ID is equal to inflam underscore plus patient ID. So you might be thinking like, what does it mean to add? Oh yeah, so patient ID is a string like we saw earlier, it's text. So you might be thinking, what does it mean to add two strings together? So in Python syntax, what that means is you take one string and then you just kind of stick them together. And this is referred to as concatenation. which I don't know, it's kind of just fun trivia. You don't really need to know the name, but all you need to know is it just sticks the two strings together using the plus. If it were an integer, it would just add the numbers. If it's strings, it sticks them together. Okay, so we have variables, we have data types. Then there's this concept of functions. Functions are, they're kind of like operations, like plus, like, arithmetic operations, but they kind of do weird or fancier different things. So a very popular function, and one that we're going to be using a lot, is called print, which will display stuff to the screen. I'll do this: print weight in pounds, just enter, and it gives you a number. Print weight in kilograms, and it gives us the other number. And I guess if we were like really untrustworthy of Python, we could multiply 60 times 2.2 and verify that that's correct. But I have complete confidence in Python, so I'm not going to do that. Let's see, what else? Oh, we can print strings. Print patient ID. Oh, I think I kind of glossed over this, but maybe this here is not quite so clear. But this is kind of an interesting idea. If you're new to the world of programming, you can take the old value of a variable and then kind of use that to modify and create a new version, but save it under the same name. So in this case, patient ID is equals to inflame plus the old value of patient ID. So that's kind of interesting. Yeah, so sorry, I got a little bit distracted. But anyway, yeah, so you can print, it doesn't have to be one single argument. You can put lots of different things. In this example, weight in kilograms. They really like to do this colon thing. Throws me off all the time. Weight in kilograms. So what this is doing is it's calling print on 1, 2, 3 different things, patient ID, and then a string that we've just created on the spot, and then another variable. And so what the syntax does is it puts a space in between each object. Okay. Now, what about this? Print. There's another function called type. So if I do 60.3, for example, close all the parentheses, it will tell you what kind of data 60.3 is. And in this case, it's a float. And if you don't remember, float is a fancy way of saying a decimal number. What about this? Print type patient ID. It's telling you it's a string. So that's kind of like interesting. Okay, and then one thing they want to explain to us is we can do arithmetic in functions. So if I say weight in pounds, then 2.2 times weight in kilograms. Yeah, so it's going to kind of give you what you expect. But this is kind of interesting because you can, like, on the fly, you can create, I guess, new values. So this could be something really, really complicated, this operation right here, or it could be something simple. And sometimes it's useful to put a lot of like crazy stuff in here. And then, so what's happening is print, it takes this value, it takes this value, and if it has to, it'll evaluate this value and then stick the results together. And then this is kind of like a cute way to think about it, I guess. There's a sticky note assigning a value to a variable. And then this is the format of software carpentry, but they like to put little tests at the end. I'm sure if there are any software carpentry people in the room right now, they'd be upset at me for saying this, but I think I'll probably skip most of these tests. But yeah, if you want to check your own understanding, this is a good way to do that. So for example, you could follow along and then, it's like a little game you can play where you can say like, oh, what's mass and what's age going to be at the end of each statement. And then you can click on this little thing and have the solution spelled out for you if you still don't quite get it. But this key points thing is pretty interesting. So we'll just read them real quick or summarize them. So there's things. So we're using Python. Python has basic data types, and some of them are strings, integers, floating point numbers. We can assign values to variables using this syntax, variable equal value. So we're assigning something called value into a variable, and we're naming that variable, which is not very imaginative. And then you can use the print function, and then there's other kinds of functions that exist. Okay, and Zoom is blocking, I think, the little next button on my chat. So I'm going to have to scroll back to the top. Okay. See? All right. So now we're going to start looking at some of those data files that we just downloaded. And can I see those data files in here? If I click this refresh button, I think it's this folder here. Yeah. Okay. So hopefully you all have a directory in your Jupyter Notebook interface that says data. And we're going to use it. And actually, while I'm at it, I'm going to just save this notebook. Okay. So we talked about some built-in functions such as print and type. But they're, Python by itself, just the built-in stuff, it may not have features that people want. So a strength of Python is that people that really like Python and have like very specific problems that they're trying to solve, maybe not that specific, they just have problems that they're trying to solve, they can create their own libraries of functions to do tasks that are useful to them. And then if they think it's going to be useful to other people, they'll share it. So one such library is NumPy. And it has all kinds of fun and neat features, and it's quite popular. So just kind of one thing to keep in mind when you're deciding on using software is it popular? Not just because you want to like follow the crowd, but the popularity is important because there's other people using it that you can get help from. So if you're using some like obscure library that has features that you really like, but no one is using it except for like you, then if you get stuck, that's going to be a problem. But NumPy is very popular. You could pretty much type, how do I do X in Python? I mean, in NumPy, and probably someone has done it or is trying to do it as well. On Python, if you want to use an external library, you use this syntax, import NumPy. This is one way to do it, and that's how we're going to do it in this workshop. You may also see something like import NumPy as NP, and that's another way, and I think that's how most people do it, but we'll just ignore that. Just be aware that that's something that people do sometimes. So with this statement, we are now allowed to use functions that have been defined in the NumPy library. So one such function is called load text. And what load text does is load data that has been saved as a text file. Very aptly named function. So I'm going to type numpy dot load txt fname equal, and I'm just going to type this in as it is, and then it won't work, but we'll see why in a minute. Inflammation dash o1 dot csv single delimiter equal comma. Okay, so I'm gonna hit enter, shift enter, and I get this kind of angry looking message at me. And then it says at the bottom, inflammation o1.csv not found. And that's expected because in this current directory, what I'm going to call the working directory, there is no such file called inflammation o1-csv. It's actually in data. And actually, I've never done this before, but I don't see why this wouldn't work. But I just click on it. Oh, look at that. So if you click on a file, it shows you in like a cute little table format. Okay. So yeah, so the reason I bring this up is because we have to change this path. So it should say data / inflammation o1 CSV. Oh, that's not working either. That's probably a typo as well. Inflam. Let me just copy this. What did I do wrong? Fname equals data. ls data / inflammation -o1 CSV. Huh. Kind of curious. What if I run it like this? No. Okay. Import OS. Excuse me while I debug this. Okay. Yeah. No such file. Okay. Okay. How is there no data? os.lister. Come on now. Where am I? Am I in the correct directory? I'm lost. Is there like a current directory? Let me just look this up real quick. If I do this, os.lister home1 esul/data. Okay, that works for some reason. All right. So if all else fails, we'll give the full path. I was kind of hoping we didn't have to do this. home1 /csul/data / inflammation -o1.csv. Okay. So that's a lot of work. All right. So if you encountered a similar issue, just put in the absolute path for file name. Absolute path to where the CSV file is saved. And the result is it prints out this thing and it says array and then some numbers and then ... and then some more numbers. So what this ... means is it's the data that it loaded is too big to display on the screen, so it truncates it and you only get to see part of it. So that's kind of interesting, but it's actually not that useful to just have data printed to the screen like that. So typically what people do is they'll take this value and they will save it as an variable. I feel like I'm having issues. Oops. I'm going to call this data. Data equals numpy.load.txt. Okay. And then just to verify that the variable is correct, I'll print data and it should look similar to what we just saw. Okay. And while we're here, we can do this print type data. Oops. Oops, oops, oops. Okay. So the data type says numpy.ndArray. So ndArray is a kind of data that is defined in the NumPy library. So what is ndArray? It's a two-dimensional, well, it doesn't have to be two-dimensional, but in this case, it's a two-dimensional list of data. If we want to know what kind of data is being stored in this ndArray, you can do print data.d type. I cannot type. There we go. So this ndArray holds float 64 data, which means like 64-bit, I think. But for our purposes, we'll just ignore the 64 and we'll just look at float. It's float data, so it's decimal numbers. We can also do some kind of fun, interesting diagnostics, I guess. Print data.shape. So the syntax, this like something dot something else is kind of interesting. So the object is called data. So if you were to go and look up what an ndArray is, there's different functions associated with ndArrays, and then there's different like I'll just call them attributes. So what we're doing with this is we're saying, what is the D type attribute for data? What is the shape attribute for data? So this is, we're just kind of like inspecting attributes of data. Okay, so the shape is 60, comma 40. What does that mean? So this data, we can kind of think of it as a matrix or a two-dimensional array. But basically, there's rows and there's columns. So here's one row, goes across. Columns are the ones that go up and down. So it's saying there's 60 rows and 40 columns. So why are we calling attention to that? Because what happens when we want to inspect individual elements of this ndArray? So they want us to do this kind of verbose thing. First, value in data, and then you use this kind of interesting looking syntax. You put these brackets. And what this is saying is you want row 0 and column 0. So evaluate that and it says 0. And we actually, we can see that. This is row 0, this is column 0 of data. So this is one that was not truncated. We can also look at, I'm just going to copy and paste this. First value in data, 30, 20. And what is it? Middle value. Middle value in data. So it's just going to give you a value. This kind of drives people a little bit crazy, this concept of starting at 0. Some people hate it and some people love it. just that's what happens in Python. Some programming languages, they start at 1, some they start at 0, and there's pluses and minuses, but the people at Python and the people at NumPy, they like counting at starting at 0. So that's the convention that we'll observe. And here's a cute little picture. If you have a 2-dimensional array, A, B, C, D, E, F, G, H, I. So if this row and column concept is kind of confusing, you can kind of look at it like this. Here's row 0, here's row 1, here's row 2, here's column 0, column 1, column 2. And then you can kind of look at the cute little colors and stuff, and you can see like which what goes to what. So for example, 2, 1 is not the same thing as 1, 2, that kind of thing. So you can look at that at your leisure. There's also, so we've extracted pieces of this n-dimensional array, like individual elements. But what if we want to extract sections? Python has a concept known as slicing. So I'm going to do this. I'll just type it out and then I'll explain it. So print data 0, 10. Okay. So using this syntax, we get a smaller thing that looks like an n-dimensional array, and that's what it is. And it's 1, 2, 3, 4 rows, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So what is this syntax? You can kind of guess the 0 through 4 and 0 through 10. Maybe that has to do with how many rows and how many columns. And what it's doing is it's saying, I would like a piece of data. And with this colon syntax, you're saying, I would like rows starting from 0 until 4, but not including 4. And I would like columns starting from 0 until 10, but not including 10. And then because we start counting at 0, we get 4 rows and 10 columns. If we wanted to, we could change this 5 through 10, and it'll give us the next, what's this, 5, 1, 2, 3, 4, 5 rows. And then this is kind of interesting. Small equal data. This is a weird syntax. 36 colon print small is print small. So you can kind of see just from the output of print that this gets a small subset of data. But what is this? There's like colon number, colon, sorry, number colon. This looks kind of weird. Well, it's like kind of a quirk or a fun feature. I don't know what you call it. But if you leave off a number, there's supposed to be a number here. In the previous example, we put a number here. But if there is no number here, Python interprets that as starting from the beginning, go to third row, but don't include third row. And then this is kind of the opposite. Starting from 36, go to the end. So I don't know. In some ways, it's kind of cute, but me personally, I think this looks confusing. I would just put a 0 here and then 40 here or something. But you may encounter this looking at other people's code, or maybe you like this and this makes total sense to you. But yeah, so just be aware that people do like to do this kind of thing. So even if you don't remember what it means, just know that this is valid Python syntax, and you can just look up slicing data in Python, and then you'll probably find a tutorial that explains this weird, unusual looking syntax. How are we doing on time? Oh my goodness, it's almost been an hour. Um, I'm laughing because we're nowhere near close to halfway done. Uh, so we'll get as far as we can get. This material will always be there. But maybe I'll skip things if I feel like the point has been made. Okay. So what did we just learn? We learned how to load data from a text file. We learned how to like do some diagnostic stuff. We learned how to look at individual elements of data. We learned how to grab sections of data. And now we're going to learn how to do operations on the data. So this is what makes NumPy so popular. One of the things that makes NumPy so popular is you can take this ND array object and you can do a function like numpy.mean on it, and it'll automatically read all of the data and it'll just know to add them all up and divide by the total amount and then calculate the mean value of the entire array. Print numpy.mean data. So you could create your own version of this function, but it's just nice that someone has done it for us already. And all you have to do is type numpy.mean data. I'll skip this because don't need to know that. I guess, look, not all functions have input. You can just have empty parentheses. It just works. Okay. Let's see. So some people like to do stuff like this. They'll want to know the min value, the max value, the mean value, the standard deviation value. And so I'm just going to copy paste this. We can see, look, it's so easy. Well, so easy thanks to the magic of NumPy. So we're operating on the entire data set. What if we just want to operate on parts of the data set? So in this example, this data set represents inflammation for patients across time. So if we look at this, so a row is a patient's data. So I can say this is the inflammation on day 0, inflammation on day 1, blah, 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 last day. Here's the second patient, day 0, day 1, day 2, blah, 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 blah. So what this example is saying is, I want to know what was the patient zero's inflammation data. And we can do that with this syntax. So I'll do patient 0 equal, and then we're going to take a slice of data. We're going to take the 0th row for patient 0, and then we'll put just a colon. So what this does is starting from 0, go all the way, starting from the beginning, go all the way to the end. And then, oops, I didn't mean to do that, but that's fine. Print max. Actually, let's just print it. Print patient 0. So we have, do I even need to do this? Patient 0 dot shape. Yeah, so this is saying it's 40 long, and then there's no rows, no columns. It's just a one-dimensional array. All right, so we've done this slicing technique to grab a piece of the data. And if we wanted to look at the maximum value in this, it should be 18 just because we can visually inspect it. There's the NumPy max function. And then actually what we did, it wasn't really that efficient because as we saw earlier when we were doing the print function, we can kind of cram in a whole bunch of like data manipulation. So that's what's happening here is instead of creating a variable called patient1 or patient2, you can just use this slicing syntax that we used earlier. We just changed 0 to 2. And then the result of that, we're going to feed that into numpy.max. And then the result of that is going to get sent to the print command. Okay. So this is two-dimensional data. So now they're saying, what if we want to know the maximum information in two different ways? And that is the maximum information for each individual patient and the maximum information for each day. So what if we wanted to do that? So we could probably think about different ways to create our own method for doing this. But actually, one of the nice things about NumPy is it has this weird thing called axis. And so you can say, I think I just noticed something. This is maximum information or the average of each day. Okay, maybe I read that wrong. But anyway, we want to know the mean value of axis 0 or axis 1. And to be honest, I'm not sure how they determine which one is axis 0. To me, axis 0 would be rows, but I don't know. My understanding, they should be flipped, but I'm just going to take their word for it. So if I just want to know the mean information for each day, I'll do this syntax. I'll type it in print numpy.mean data axis equals 0. Oops, and what did I do wrong? I didn't close a parenthesis. Okay, so it gives you some numbers that are kind of like hard to look at. There's a bunch of decimals and I don't know, I feel like my brain's glazing over just looking at all this. But yes, there are numbers. And then if we want to make sure that we use the correct axis, which I would probably be doing this all the time because this axis thing, the order of the axes is kind of confusing. We can do this shape, look at the shape attribute, and it says 40. So if we had axis 1, for example, it'd give us 60. So that would help us determine if we're using the correct one or not. Oh, I'm saying, oh, we can run it on the other axes. Okay, so that's kind of interesting and fun. Okay, I'm going to skip over this. What did we learn? This is kind of a lot to take in. What did we learn? We learned that there are things in Python called libraries, which are kind of like collections of functions. To use a library, you do this import syntax, and then you have access to all of the functions in that library. We learned that NumPy has a bunch of useful functions such as load text, and it creates something called n-dimensional arrays. And we learned this crazy syntax with these brackets, this row column brackets. weird column syntax so we can get slices of data. And then we used some NumPy functions to do operations on pieces of the data or maybe all of the data. Okay, so it is 2:05. We're at the halfway mark of the time that I've allocated for us. So let's take a 5-minute break, and I will be back at 2:10. I'm gonna get some water real quick, but if you have any questions, you can put them in the chat. Otherwise, let's meet back in 5 minutes. Hello, everyone. Back. We have a question. What's the difference between log out and shut down? Let's see. Shut down. Let me save this actually. Pray. I don't know the difference. I'm guessing. I'm very curious. I kind of want to click on one.
You can do that later if it's easier.
Yeah. It seems like the same thing to me, but actually that reminds me, we can look at this page here on the on demand. Yeah, we'll do log out or shut down at the end. Yeah, we can see like we have an hour and 5 minutes. There's a bunch of different things that you can look at, but like we're running a kernel right now. And perhaps you've noticed as we run stuff, there's like numbers and stuff going on. So I know there's, if you can shut down the kernel, you can restart the kernel. And what that will do is it'll make it forget all of the stuff that we previously run. So for example, we're using NumPy functions in this line right here. So if we restart the kernel and then run just this line here, it'll say, I don't know what numpy.mean is, and then give an error. So you either have to re-import NumPy or you have to go back and evaluate it. So my guess is that shut down might mean shut down the kernel, and log out might be to just like end the notebook session, but I don't know. We'll find out. I'm very curious now. But yeah, either way, save before you click either of those buttons. Okay. Let me just scroll through this real quick. All right. So we have an hour. Kind of everything, almost everything hinges on a little bit on this.
So excuse me, I kind of found out what log out and shut down will do. If you log out, you can always connect back to it's completed and you cannot log back in.
So you're saying if you log out,
you can always connect back, but if you shut down and you go to your interactive sessions, the active sessions, you'll see that that's completed there.
So shut down will end the job.
Yeah, just like those two completed things that you have right there. But if you log out, you always have that connect to Jupyter.
It's still connected. Okay, that makes sense.
Okay, yeah, thanks.
I wondered, yeah.
Of course.
Thanks for sacrificing your job.
No, I didn't sacrifice. I created a new one and yeah, just set it on.
Okay, cool. Thanks.
Of course.
Okay, so we're going to look at another library called matplotlib. And this is a library of functions for making plots. And while I'm fixing my hair, I will say I never actually went into why this is the case, but why do they have this .py plot? Why can't it just be matplotlib? I don't know why, but that's what it is. But you will often see, so I'm going to type import matplotlib.pyplot. You'll often see this as PLT. So they won't even call it matplotlib.pyplot. They'll just call it PLT. And you'll notice, for example, when you use functions like this imshow, it's matplotlib.pyplot.imshow. The reason why you may see stuff like this as PLT is because then you can just type in plt.imshow. So it kind of saves you some typing. But we'll do it the whole way because I don't want people to get confused and see there's a disconnect between what I'm typing and what's being shown on the slides. And then matplotlib dot pyplot dot show. Okay, hopefully I didn't type anything wrong. Oh, there it goes. Matplotlib. Matplot is not defined. Matplotlib. There we go. Yeah, see, I knew I typed something wrong. And I typed another thing wrong. There we go. Pyplot. There we go. Look at that. So you get a cute little picture. So what it's done is it's taken the data from the file that we loaded way earlier, and it's represented it as this interesting looking picture. There's no legend, so you'll have to believe me, which in turn I'm believing the software carpentry explanation, but it's saying this yellowish stuff colors represents the maximum values, and then this dark blue represents the minimum values, and then as it goes from like blue to greenish to yellow, it's increasing. So you can kind of see overall there's like a trend of going up and then coming down. Okay. So I'm going to start maybe copy pasting a little bit more instead of typing. So what is this example saying? You can see information rise and fall. What if we want to look at the average inflammation over time? So remember earlier we did that numpy.mean, and I missed a parenthesis. We're saying average inflammation numpy.mean over axis 0, and then we're just going to use pyplot. And the thing on average over all patients in that file, we get this kind of increased trend, almost linear looking trend, and then an almost linear looking decrease. So that's kind of interesting. Here's another kind of diagnostic interesting plot that we could make. We could just look at the max, and we get basically a linear increase, linear decrease. And then the min, we could do a min. That's kind of repetitive. Same idea, you get this weird kind of stepping thing. And the software carpentry materials are very suspicious of the stepping function. They're saying, hey, I don't like this, but I don't know. It's just data to me, so I don't know what it's supposed to look like anyway. Okay, so I'm going to copy paste this too, because there's just a lot happening. Oh, I remember. Let me just type this out. Home1, username, data, / okay. All right. So this is kind of interesting. We've created one figure. You can kind of see as I pick it up, it goes together. We've created one figure, and this one figure has 3 subplots associated with it. So here's axis 1, axis 2, axis 3, and these are subplots. And then we can assign different data to plot. We can set like labels. We can do all kinds of different things. So this just is really basic. You're just showing the data and giving it an example. So this is kind of interesting. And people do like to do this kind of stuff. And then if you really are proud of the figure that you've created, you can save it. And so somewhere in here, if I refresh, I should see an inflammation.png file somewhere. But I don't see such a file. Refresh. ls-lrt. Oh, that's sad. What happened to my file? Okay, I guess you don't see a file that's saved. I'll look into why that is. Okay. Oh yeah, so they talked about this plot. One thing they say is if you are very, very observant, you can see the height of here is 12. The height here, max height is 20, height here is 5. But looking at it, they all kind of visually, they all look the same. So they're saying if you really wanted to, you could change the scale of this so that it's all the same. So like the max would be much bigger than the min, and maybe the average would be in the middle. So there's all kinds of like fun visual things that you can do with these graphs. Okay, so let's go on to the next one. Let me just scroll in this really quickly. Okay. So in the previous slide, we learned just how to use matplotlib, sort of more like we were made aware of matplotlib. So next, we're kind of going to go back to more built-in features of Python. So there's something called list. This is a type of data. So odds equal, and we can create a list just like this. Oops, 7. And we can do operations on lists. Odds are, and then odds. Okay, so there's our list. Lists are very similar to arrays. I'm just going to copy paste this. You can grab individual elements of the list using this bracket syntax. So this will grab the 0th element, which is 1, or the first element. This will grab last, so 0, 1, 2, 3. So it should be 7. This is kind of interesting. -1. What does that mean? -1 means the last value. So if we wanted to get the second to last value, we could put -2 here. That would make this statement wrong, but you kind of get the idea. -2, second to last value. So sometimes it makes sense to just do -1 if you don't know the length of the list. Okay. Now what's happening? Oh, you can assign values to the list. So here's an example. They create a list, Curie, Darwing, and Turing, and they print it out. So here it is with the incorrect spelling. Then they say, oh, I want to fix that. So you can say, I want to take element 1 of names and set the value. And so then that's what they did, and that's been corrected. But what they want to bring your attention to is we can take elements of a list, we can change. So basically we're changing the list, but we can't take like pieces of a string and change it. You can't take like, so in this example, you can't take Darwin and then decapitalize the D. And then it goes into this explanation of something called immutable and mutable. So some things you can change, some things you cannot change. Things that you can change are things like lists, and then just like raw data types such as integers cannot be changed. Basically what you do is you just replace the old value with a new thing. So in this example, you wouldn't just change lowercase d, you just have to give it a whole new name. I mean, a whole new variable, sorry, a whole new value to this variable. Okay, and then this is a really interesting example. So let's say you have, and I'm going to type this out because I think it's that interesting. So you have a list that we're making, a list of salsa ingredients. So peppers, onions, cilantro, tomatoes. Okay, so there's our list. Now let's say we wanted to make a duplicate. So my salsa is equal to salsa. Okay. So what we expect intuitively is that if we print salsa and my salsa, they should have the same value. So print salsa, print my salsa. Okay. And it's correct. They do have the same value. So what's happening is Python is not creating a second object. It's saying my salsa points to the same thing as salsa, which is weird. And it's kind of a weird way to explain what's happening. And it's also just like weird. Why would you do this? What is this weird behavior? But I'll explain a result of this behavior, which is if you take salsa element 0 and you set that to, instead of peppers, we're going to call it hot peppers. So we've changed the value of salsa. And that change has been reflected in my salsa. And if I wanted to do something like my salsa, I know I'm going a little bit off script here. Super hot peppers, I guess. We run this, they both change. So when we do this syntax, just be aware, like, I don't know what people are going to remember at the end of this, honestly, but just be aware that when you're making duplicates of data, it's possible that the duplicate can affect the original data and the original can affect the duplicate. So just keep that in mind, that this behavior is possible. And sometimes this is a good thing and sometimes this is a bad thing, but just be aware of it. And they're saying, if you want them to be independent and not affect each other, you can do this syntax here. My salsa equal list salsa, and this will create a duplicate. And now I can say my salsa element 0 is equal to, I don't know, mild peppers. And then print. So the behavior is different. So one changed, one stayed the same. So just keep that in mind. And then a list can contain other lists. So here's a weird example. Here's X. The first element of X is a list that says pepper, zucchini, onion. The second element is cabbage, lettuce, garlic. Third element, apple, pear, banana. So you can have a list of lists, and they have a fancy word for this, which is, I don't know if it's that fancy, but it's called nested lists. Then they have a picture, which looks like someone was bored late at night at a restaurant or something. So X is a variable and it contains a container. It contains containers of pepper. Okay. This syntax is saying, it's kind of like saying you took a container of pepper and put that in a container. This syntax is just like saying a container of pepper, and this is saying like you took one pepper particle out of a container of pepper. So use the double bracket when you have a nested list, double bracket syntax. So you're saying, I want the first element of the first element, if that makes, or the 0th element of the 0th element. I don't know if this is that useful, so I'm just kind of breeze over it, but yeah, you can operate on lists. You can change them. There's .append functions, .pop, .reverse. You can do all kinds of fun things with lists. Earlier when we had that weird colon syntax, so 0 through 10, it's the same idea. Starting from 0, you can go through 10, but sorry, 10 up to 10, but not including 10. That's that whole same idea. I know I kind of like maybe didn't explain that as well as I could have, but just what did we learn? We learned that there's things called lists in Python, and they have their own unique functions, and you can have nested lists. You can create copies of lists. So there's just things called lists. And it's a built-in Python function. Okay, how are we doing on time? We have about 30 minutes. So I hope that we can get through at least this section, maybe the next one. Because we're actually getting into like kind of useful stuff now. So loops, if you have done any kind of programming before, you may be familiar with this concept of loops. What is a loop? It allows you to repeat actions multiple times using like the same code, but maybe a little thing here or there changes. So in this example, we want to run the print function on an element of this odds list. So one way to do that is to just copy paste, manually type out or copy and paste. That's what I'm going to do. Oh, let me do this real quick. I know this seems kind of weird, but in the context, oops, man, I cannot type today. There we go. I'm going to save. So in the context of Jupyter Notebooks, it's just nice to have this so you can have important stuff nearby. All right, so odds. So if we want to repeatedly print out every element in odds, what we could do is we could just type print odds 0, print odds 1, print odds 2, print odds 3. That is something that we could do. But that is a horrible idea. Why is it horrible? One is because it's boring. But they don't put boring actually in their list. For me, that's the most important, is it's boring. But they say they give much more, I guess, serious reasons, which is it's not scalable. Which means if you have a very big list, you're not going to type print a whole bunch of times. That's crazy. Difficult to maintain. It's fine for a small amount of lists, for a small amount of data to do this. But when it gets big, it's going to be hard for people to fix. If you have to change something, people have to go back and forth. Then they say fragile. What if the list changes? So because this is a Jupyter notebook, I can do something like this. Just delete 7 and then rerun the cell. And now it's mad at me. Index out of range. That's because there's no odds 3. So I've basically taken working code and now I've broken it. Oops. So a better way to do this is with a for loop. So we'll start off with this odds. I'm just going to copy paste this part. Sometimes this kind of reminds me of those old like Mavis Beacon teaches typing games where there's like all these weird characters you have to type in, and I just like fumble. All right, so I'll just type this for variable in list colon and then body 1, body 2. So that's just an example of the for loop syntax in Python. So you get a list. Sorry. How do I want to explain this? It starts out with, we'll say body 1 and body 2. This is the code that gets run repeatedly. So in this example, we're actually just going to run this print syntax. But I also would like to draw your attention to Jupyter Notebooks is smart. It knows about Python. So when I hit enter, you can see here when I hit enter, it starts a new line. But and even in the same cell, odds equals something. And then I hit enter and I got a 4. Underneath the for loop, it automatically gives you this white space right here. It indents the next line. And this kind of drives people crazy. People that maybe are new to Python or people that just don't like Python. This is one of the things I do not like about Python is the indentations matter. Indentations are kind of like, it tells you what context you're working in. So this indented indentation means that everything that is indented one tab over is the body of this for loop, which means that every time this for loop runs, it's going to run stuff that's right here. So the body of this for loop is going to be print. And I'll just leave print. I'll just put print something. And then list means it needs a list of values to iterate over. So that's why we talked about list, because we're going to use odds. And then variable means it's going to take a value, a single value from the list, and it's going to save it to a variable. And hopefully you give it a meaningful name. So I'm going to call it num. So for num and odds, then it's going to do this command here, print something. I'm going to change that to num. I hope this explanation makes sense. Kind of just made it up right now. So what's happening here is it's going through the list. It's going to take the first value of odds, which in this case is 1. It's going to assign that as to the value of num. And then it's going to just execute everything in the body of the for loop. And in this case, there's only one value, which is this print statement. So the nice thing is that this code here doesn't need to change, but the value of num will be different each time. Hope that makes sense. And if you are familiar with the concept of for loops, I hope that wasn't too boring of an explanation. Oh, another thing I forgot to mention is this colon thing. This is just syntax of Python. Sometimes there's like stuff that happens in programming languages and you wonder like, why is it like that? Why did it have to be this way? These are all kind of interesting, fun trivia questions. But practically, it's just the syntax that Python is expecting. If you don't include this colon, it's going to get mad at you. Invalid syntax. Saying, I don't know what that means. What about this if we get rid of the indentation? Unexpected indented block, which isn't really that helpful of an explanation. It's just saying you need an indentation for expects an indented line. Okay. So now we're all experts in Python for loops. We can start doing some interesting things. So yes, we could just print elements of an array. Here's an interesting one. Maybe we'll start skipping stuff even faster after this. This is, we're given a list of names and we want to calculate the length of the list. So what's going to happen is it's going to, for value and names, and it's actually not even using the value variable. It's using a different variable called length. So it starts out as 0, and each iteration, it's going to increment the value by 1. And then at the end, it's going to print out the length. So there are 3 names, which means this runs 3 times. So on the first time, Curie, second time, Darwin, third time, Turing. So that's kind of interesting. And then they bring this up, which is never do this. It's a fun example. But practically, if you want to know the length of a list, there's a function called len. So you could do len names, and it'll return the length of the list. And it actually does it much faster than you could do in a for loop. So they're just kind of warning you, even though we just told you how to do something, never do this, I guess. So what did we learn? We just learned the syntax of for loops. And I explained it like 3 times. So I hope you don't mind if I don't explain it a 4th time. Okay, now we're going to do something interesting. I'm just going to scroll down so we can see. So earlier we made these plots of average, max, min, patient data. And if you remember, there's actually lots of different files. So what we're going to do is we're going to read in each file, and then we're going to make a set of these 3 different plots. This is the perfect kind of thing that you would do in a for loop. It's very like you're just doing the exact same thing over and over again. And the only thing that changes is like the file number. It's just like really this number here. Excuse me. Okay. So before we get to that, we need to use a library called glob, which is a weird name, but basically it's a thing that allows us to give a pattern, and then based on that pattern, it'll find files that meet that pattern. I'm going to import glob, and the pattern that we want to find is this inflammation star.csv. So this is saying we want to find all of those inflammation files. So this is saying it doesn't find any, and that's because we have to put in the absolute path data. So this is saying, find me all files that meet this pattern. And then this star here means anything can happen. This can be anything at all. So what we're saying is we want to find any file that begins with /home1 CSUL data / inflammation, then it can have anything at all, and then end in .csv. So it gives us this. Basically, it matches with all of these numbers here. Okay. So this is how we're going to find files that we need. I'm just going to copy paste this code snippet, and then we'll walk through a little bit. So we saw this earlier. I have to change this. Change this. Okay. So this is going to grab every file, every inflammation file, and it also is going to sort it, because I don't know if you notice, but these are out of order. And I did not know this, but according to software carpentry people, and I trust them, they say that it comes back in an arbitrary order, which I find kind of unusual, but I guess I'll just trust them. I'm not sure why it would be arbitrary, but it's arbitrary, and so we have to sort it. Then we're going to use this slicing syntax, and we're just going to pick the first 3 files to look at. Then in a for loop, we're going to print the file name. We're going to load it using the load text, and then we're going to make 3 different graphs. And then it'll increment and go to the next one. I'm going to hit enter, and we'll see this behavior. So remember, it says print file name. So this is kind of our way to tell us what are we looking at. We're looking at inflammation 1 data. So here's the average, here's the max, here's the min, and this is all over 40 days. Then we're looking at the second file, then we're looking at the third file. And this is pretty neat. If we wanted to, we could change this to like 10. And we can see a whole bunch of stuff. So this is kind of like the joy of Jupyter Notebooks. You can just change a thing real quick, and then you have the pictures and the feedback right away. I'm just going to save this real quick. Okay. And then, of course, the software carpentry people are very suspicious of this data. They're saying, hey, what's going on here? Why is this flat? Why does this look like a step? What's this? I'm curious. I'm not going to run this. I just want to look at it. Oh, they're just giving us the answer. They're saying plot the difference between average inflammations between first and second data sets. The difference between the leftmost plots of the first two figures. Oh, so I just want to know, how are these different? Okay, yeah, you could do that. Maybe I'll do that in my free time. Okay, so what did we learn? We just had, this is more of like an example, a useful example of for loops. That's much more interesting than like printing elements in a list. How are we doing on time? We have almost 10 minutes. My watch is like different than the actual time. We have, we'll just say 10 minutes. Okay. Let me just look at this. And then let me look at the next page, because that actually may determine if I want to talk. Okay. So actually the next two are pretty important Python features. And since we only have 10 minutes, we don't have enough time. I don't know. We don't have time to do both, but they're both important. So I'll just pick the, we'll do half of each, sort of. I'll just kind of give you an overview of what the pages are. And then if you're interested, you can go back to this page and you can read along. Okay, so basically what we've done so far is we've created code and it just does exactly what we do, what we've told it to do. And then this is saying we could actually have our program make decisions for us. And that's kind of interesting. But in order for it to make decisions for us, we need to be aware of something called conditionals. So you create kind of a conditional statement. And what happens is a conditional statement will evaluate to true or false. And then based off of something being true or false, you can have a different thing happen. So here's a super basic example. You have a variable called num, and you create this conditional num greater than 100. And then you use this if statement, if, and then a conditional, then a colon, and then here's that indent again. And so what this is saying is if num is greater than 100, it'll do this print thing. Print statement. And this is indented. So when the indentation stops, that's how it knows that the if statement is over. Then it's saying if num is not, so if this evaluates to false, then it will it'll run what's in this else statement. So basically the summary of what's happening here is if num is greater than 100, it'll print greater. Otherwise, it'll print not greater, and then it will always print done at the end. So let me copy paste this. I can run it, and then we can kind of mess around with it. So not greater, done. So 37, not greater than 100. That's kind of simple. What if I do 100? 100 is not greater than 100. It's equal to, but not greater. I can do 101. Now it's greater. So this is kind of like, if you can imagine every different scenario that could happen, or maybe most scenarios, you could have your program created, make a decision. So here's another feature. You can do an if, which we've seen before. Then there's something called elif or else if, meaning this is not satisfied, check if this is satisfied. If this is not satisfied, then do the final thing. Another thing they want to let you know is it doesn't even have to include an else. Often you'll see an else. But you could just say if num is greater than 100, then do something. And if it's not the case, then it just continues on and ignores there's nothing to ignore. It just continues on. I guess it ignores, yeah, this part right here. Okay, so then there's all kinds of really fancy things, like there's ands and ors, meaning if this is true and if this is true, meaning they both have to be true, then you can have, it'll do this, otherwise it'll do that. So if just one of them is false, then that ruins the whole conditional and you have else. Then there's something called or, which means only one of them needs to be true. So if either this one is true or if this is true, either one, it'll run. Oh, and then they give you the special word, true and false. These conditionals, they evaluate to true or false. So if I do 1 less than 0, false. 1 greater than or equal to 0, true. So that's kind of what it's looking at. It's looking at true or false. Okay. So just be aware of that. And I know I'm skipping over this. I feel a little bit bad, but life goes on. Okay, next is functions. So what is a function? We've seen functions already. We've seen like the length function. We've seen the print function a lot. We saw the type function. So functions are kind of like custom operations that you can do. So here's an example, Fahrenheit to Celsius. Some functions take arguments. So this is saying I'm going to create a function using this def syntax. And then the name of the function is FHR_2_Celsius. Usually you want to give your function a name that describes what it does. So Fahrenheit to Celsius kind of makes sense, I guess. If you didn't read the text of the function, you would just assume, oh, okay, must convert Fahrenheit to Celsius. So this is saying it takes as input something called temp. So if you give it a value, you give your, we'll kind of skip ahead. Fahrenheit to Celsius, this is how you use Fahrenheit to Celsius. You type in the name of the function, then you do a parenthesis, and then you give it a number. So what's happening here is it's saying we're going to call that number temp. It can be any number at all. And then it'll evaluate, it'll run the body of the function, which is one line, which is this return, and then this like the Fahrenheit to Celsius temperature conversion formula. So what is a return? It means that when you run this command, it'll return some number. So I hope that made sense. I would like to also draw your attention to this. We have this colon syntax and then an indentation. So keep that in mind. The body of the function is indented. And that's how it knows that's what the function is and when the function ends. Let's see. Yeah, so once you've defined a function, you can just go ahead and use it. And as far as Python is concerned, it's almost as if like it's a built-in function now. What else? What else? What else? You can have a function call another function. Variable scope. I think this is a good point to end because I also forgot to mention a variable scope in for loops. But when you create a variable in a for loop or in a function, the variable exists inside the for loop or it exists in the function and then it goes away at the end. So here's an example. It's kind of hard to read because I've skipped a whole bunch and maybe you're kind of like have no context, but I guess just trust in me when I say there was a variable called temp k inside this function here. And then in this example, they're trying to call temp k again. Oh, here it is. They're trying to call temp k again, but temp k only existed in this function here. So when the function ended, temp k disappeared. So what's happening is it's saying, I don't know what temp k is. It's not defined. So that's what it means by variable scope. So same thing in our for loops. Let me go back to this for loop example here. So like fig axis 1, axis 2, axis 3. If I type fig 1 or axis 2, axis 1. Oh, axis 1. That's right. That's because we had it defined earlier. So that's a horrible example. What if I change this to 4? So rerun it. There it goes. Axis 4 not defined, of course. There it is. So there's something called axis 4, which was created in this for loop. Now I'm going to go over here. I'm going to call axis 4. Oh, it's still, okay, maybe my understanding is not what I thought it was. But variable scope, keep in mind that variables exist in some, you can refer to variables in some situations that you can't in others. So when you just need to be aware of that. And the variable is called outside of, for example, this file names variable. This is considered a global variable because everyone can see it. In this function here, it's called a local variable because it's only visible within the function. And I thought that was the case with for loops. It's that way in other languages, but I guess it's not the case here in Python. So variable scope can be kind of confusing, but it's important because you could be using variables, you could be using data that you weren't expecting to be using. So just keep that in mind. And as is the nature of these workshops, we cannot cover everything. What is this next one? Errors and exceptions. Yeah, this is pretty advanced stuff. What do you do when something bad happens? So you'll have to read this on your own, or perhaps we could do like an office hour session and we can talk about it, what to do when you have an error in your code, how do you handle errors, and how do you create exceptions for those errors. And we can go on and on for all these pages, but we gotta just stop somewhere. So I'm just gonna arbitrarily stop here. So thanks everyone for listening. Thanks for attending. If you have questions, I'm happy to hang around and answer any questions that you have. Or you can send email to us, all that kind of good stuff. But yeah, so that's all I've got. Thanks for attending. Let's see, I'm gonna click that button. Log out, shut down. I forgot which one was which already. I'll do log out. What happens? I've logged out, okay. If I go here. So it says I have 17 minutes, so I could, in theory, restart my Jupyter notebook. Ooh, look at that. It's starting up. And it's being a little bit slow. Okay, yeah, look at that. Okay, and what if I do shut down? You're going to shut down Jupyter Lab. Okay, so I shut down Jupyter Lab. Okay, and it's completed. All right, that was fun. All right, everyone, I'm just gonna stop. Otherwise, I'm just gonna start checking emails and stuff. All right, bye everyone. Thanks for coming. Have a great weekend.